so we can see what happens to the water. Green. Seemed appropriate. Now, what I'm going to do is I'm going to light this match. After I light this match, I'm going to invert, put this graduated cylinder over the top. And I want you to answer number 1. If the water level rises due to a change in the amount of gas, when would the water start to rise? Either when the candle is lit or when the candle does what? Goes out. Because eventually it will go out. This. You're going to let that burn for a little bit. So number 1, make your hypotheses on when and why you think that will happen. After you filled in number 1, if the water level rises due to a change in temperature, when would the water start to rise? Fill in what you think for number 2. And then we'll see if we agree. I'll give you some time to do that while I'm still setting up.
I'm supposed to be filming this?
Yeah.
Okay. Just making sure.
For the stick little students. Help them out. When you're finished, look up so I know you're done. Put your pencils down. Today, some of these you'll get to interact with, some you won't. All right, are we ready? Anybody still writing? Okay, this half of the room, you are watching for when the water rises. This half of the room is also watching for when the water rises. We'll see if we agree. Are we ready? Kind of cool. Okay, so when did the water start to rise? When the candle what? Went out. Okay, so let's talk about what processes were happening in order for that to occur. What is the candle doing? Not a trick question. Think about why we light candles other than smell. Light, heat, right? So it's heating what? The air molecules, right? The air molecules. When we invert this over, actually, Kevin, can you grab me some paper towels? No, that flame is still heating these molecules, right? You're with me? When that flame goes out, what stops? Not why did the candle go out. When it goes out, what is stopping? We just said the candle's heating the air molecules. We're no longer heating the molecules, which is going to cause them to what? To cool. Now, yesterday you learned evaporation causes cooling, right? You need to learn cooling causes your vapor molecules to condense. So, when they condense, they're going to stick together, right? Making less vapor molecules, creating what type of pressure? Low pressure. The atmosphere is still pushing out the water in the evaporating dish, and that's going to push the high water pressure up into your graduated cylinder until it reaches what? Equilibrium. Absolutely right. Equilibrium. So you should be able to answer number 3. When does water start to rise? After the candle goes out. Why? When the candle goes out, that causes cooling, which causes condensation, creating low pressure. The high atmosphere pushes the water up until it reaches what? Equilibrium. Number 4. Oh, sorry, I'm still writing. Is the pressure inside the graduated cylinder greater than or less than the pressure outside the graduated cylinder? Everybody? Less than. After your air cools, it becomes condensed, your outside air pressure is greater. What can you say about the movement of liquids and pressure? How do liquids like to move? From what type of pressure to what type? High to low, like everything else you've learned so far in science. High to low. Make sure we fill that in.